Right, good morning, everyone. Right, so my name's Jamie. I'm going to talk to you about basically migrating the mill build tool to Scala 3. So I used to work at the Scala Center until this year, and now I'm engineer at Mebex Software. It's a small company in Zurich. My credentials: I've worked a bit on Scala 2 and Scala 3 compilers. I've introduced the Tasty reader in Scala 2, so you can, anyway. I have a website. So today I want to basically do a little walkthrough of how would you go about actually migrating a big project from Scala 2 to Scala 3, and basically what could you expect to go wrong, and then what are the things that just that I stumbled upon that I didn't really expect to happen or go wrong. And to recap, I don't know, who has ever used mill build tool? Okay, so it's like everyone in the room, almost. Okay, so I probably could skip this, but yeah, for the cameras and the stream. So mill is a build tool written in Scala, and you can use Scala syntax to basically configure your build. And why you do that is because maybe you want to customize it, but at the core, most of it's declarative unless you want to customize things with tasks. And yeah, it's compared to SBT, every task is more cached. So usually there's less work to be done than in SBT. So why do we do this migration to Scala 3? Well, Scala 3 was released in 2021, so that's getting on for nearly 4 years since that happened. And Scala 2.13 library is frozen, and a lot of new libraries are coming out that are Scala 3 exclusive, so it would be good to catch up with that. And also Scala 3, in most cases, can use Scala 2.13 libraries, so there's no problem with jumping in most cases. So here is the kind of end result that we're working towards. If you don't like optional braces, you don't have to use them. But this is the basically what you could end up doing. So we're using an enum to define the days of the week. Then we create a cross module for every day. And then we have a task command today, which would print the current day like this. So yeah, this is what it looks like in the actual editor. While Metals is working, so that's really good. And yeah, so we could do this command. I'm talking to the screen. So you would print today, and also you could that's not great. Or you can resolve all the cross modules by the enum. So that's basically that's mill with Scala 3. So that's what we're working towards. That was the demo. So how did this timeline go? I started in August 5th this year, and basically within 2 weeks I had already passed the first sort of integration test, and then by September 27th we had made the whole CI green, and then we had to do many rebases to catch up with the main development branch, and now we're at today, which is yesterday according to that. Anyway, so what did I do? Obviously check out the main branch from Comliaoi Mill. Then I picked a test. Basically, I said, I have no idea how this works. What do I do? In the README, I saw these example tests. So this is an example that I would pick. So I just run that command and I verify that it works. And then, okay, now it's time to migrate. So I changed Scala version to 3.5. And of course, nothing at all worked. There are many errors like macros, syntax. So let's see what those are. And yeah, I'll try and just plug the gaps and move on to the next test. So just trying to do everything to get this one test to pass and then move on to the next thing. So yeah, typically, obviously, you might expect some syntax errors or changes to type inference. The one big thing that's definitely not compatible is any macro definition. You have to rewrite that with the new Scala 3 API for macros. Then another weird thing it might not have is that if you use a library that has type plus derivation, then a lot of libraries in Scala 3 require this new thing called a mirror, and not all classes will get a mirror provided by the compiler. So that's to be expected if you depend on that. And then obviously you have to update any dependencies or transitive dependency conflicts. You might have to resolve that. And there might be changes in the way that Scala FMT, so linting or formatting, works, and Scala fix that changed a bit. So a typical example of a syntax error is going to be like, here we have a task and we pass a lambda to it. And in Scala 3, you have to use parentheses around the lambda arguments. So that's a very basic thing. Something that's more actually quite difficult and hard to think about, and actually you wouldn't know unless you have a test case to catch it, is that basically implicit conversions are really bad. So here we have some XML syntax, and it's an if case. So if you don't have the else branch in Scala 2, basically the else branch will be converted from units to whatever the current branch is. So you would get a conversion from units to XML, which will give you the empty node sequence. But in Scala 3, what happens is that everything becomes unit. So you'll get a unit inserted in this then branch. So then the entire thing becomes empty node, and you'll just have nothing, no XML anymore. So this entire if branch just becomes empty. And that was very strange, because you just have like, one of the tests in MIL is this, basically a check that says, do I print this XML? And then I just see there's a whole bunch of holes in this XML. I was like, where do they come from? And it's because of this if. So any implicit conversion from unit, be very wary about that, because that's basically a hidden bug that doesn't get caught by the compiler. Yeah, and we had all these terrible, weird bugs in Scala 3 that you don't expect. So one thing we have here is basically the requests library, and we're just posting some JSON to this URL, and we just pass the UJSON object here. But there's an implicit conversion from UJSON to this thing called a request blob. So that's basically the serialized bytes. And for some reason, the compiler like messes it up and tries to do this data equals inside the constructor of that. And then we get a type error, so I have to just lift that out. These are all very weird things that you don't really expect to happen. But implicit conversions, there's a reason people don't like them. Okay, then of course, I come across a macro. So to try and just get the test going and move on, I just replace the entire macro with a triple question mark, which throws the unimplemented exception. Yeah, and that basically means that any time there was a piece of code that would be removed by macro, such as this context, which basically appears whenever you use the task, it allows you to access a logger or the current file directory that you're writing to, things like that. You call this thing implicitly, and then it gets replaced by a macro. So then I have to remove this compile time only thing, because otherwise none of the code will compile and it will complain. And also you see it's a triple question mark here. So at runtime it's going to blow up. So that's important to remember. Then we have third-party macros that didn't work. So there's this macro in the main args library. Main args is a library to parse command line arguments and basically convert them to, for example, a case class. And yeah, there was some errors in that. So I replaced the call to the macro with the triple question mark. And again, this is all in the service of just trying to get that one test case to even compile. And then I'll deal with any errors later. Yeah, another thing, we have to remove any compiler plugins, because compiler plugins only worked with Scala 2 compiler. Now you have to re-implement them in Scala 3. So I just removed that because it wasn't really important to get the code compiling. All right, so now we come to this error that I was talking about with the mirrors. So in mil, every named task is basically cached to your disk. The result of running the task will be cached to disk by serializing to JSON. So basically every data type that a task returns needs to be serialized to JSON. For example, this Corsia publication class. Right. And because of that, we need to use the upickle library to serialize this publication class to JSON. And the problem with that is basically that UJSON requires this thing called a mirror. So we want a mirror of this publication class, and the compiler gives an error that, oh, there's no mirror for this publication class. Why is that? Well, if I go to the source code of the Corsia library, which you can't do if it's we can only do this because it's a open source library. It's using this data class macro, which is basically a way to define things that are like a case class but are binary compatible. And the compiler doesn't like that. It only wants to see case classes. So in fact, the error message is can't find a mirror because class publication is not generic product because it's not a case class. So how do we fix that? Because we really need this mirror. So there's two choices. Either the upickle library in Scala 3 is wrong, because in Scala 2 you didn't need a mirror. So by requiring a mirror in Scala 3, you're inevitably breaking code. So we could either change upickle to not need a mirror and do what it did before, or we can just quickly generate some mirrors and call it a day. So to just get the code running, I basically made this short script that just generates a bunch of mirror code. Like, this is very small to see, probably. But yeah, I basically had like a little script with some named tuple here, and I said, just generate me this code and I'll copy paste it. So that's what it's like for a bunch of enum values, so case objects. Then for a product type, so that was the one of these classes that isn't a case class, and one for some type. Basically, this was the problem with that is just very verbose and very fragile, because anytime you add a new field, then you have to regenerate the code. Not great, but it was a good short-term solution to just try and get that test running. So later on, a few weeks ago really, I replaced that ugly mess of generated code with a macro, of course, that will give you a mirror for any class, which is like, I don't know, a sin. You're not allowed to do that in the compiler, but with my macro you can. So all that ugly verbose stuff just becomes like 2 lines of imports. So import my auto mirror macro and my auto root macro. And basically this says like, yeah, if you want to declare a root, that basically means it's like a map, a compile time map that just stores every single mirror that is associated with publication. So if there's root classes or child classes, then it will do for that and just pack them all into one object. So we have, here's what it looks like at the definition. We have root. Yeah, so root basically has a lookup method mirror. Given some type T, that's subtype of R, then we just look it up and retrieve the mirror. And then we have this manual method, auto root, which is where you declare it. So it's like semi-auto derivation. And we only put mirrors in there that the compiler doesn't want to generate, so only the ones that aren't case classes. And then I have this sort of path as the lookup. So why do I have that? It's basically because we want a proof that T actually is a child of R, and that actually there is actually going to be a mirror stored in there. And we have this thing that basically just generates the proof that the path exists. So that's is this class in there, and then basically we have finally this auto mirror thing that says, given that you have some root that you declared manually up here, and that we could generate the proof that we have the class in there, then we do the lookup and give you the mirror. And then basically we have to do some casting to make sure it has all the type refinements that mirrors come with. Yeah, and once I'd done all that, I actually could get that one test case to compile. Obviously it doesn't pass at this point because of all the triple question marks I put everywhere. So then basically when I run the test, I just hit one of those triple question marks and I try and fix that. So here comes the real mill-specific stuff I had to deal with. So I mentioned earlier there was the problem with the main args library, so I had to go and fix that. Then we have a whole bunch of macros that are inside the library itself. We have some compiler plugins I had to rewrite. There's also some analyzer that analyzes the bytecode to make sure that when you change a print line to some other print line, that basically you have to rerun the task to make sure you get the new result. And a custom Scala parser, of course. So yeah, basically to fix the main args thing, I just forked it, did my change, published it locally, verified that I could move on in the test in mill, and then once I did that verification, then I basically made the full pull request to main args and submitted that. I won't go through what that was. It was basically just not supporting var args and not supporting, like, if you didn't explicitly put the main annotation, so it wasn't very complicated. Yeah, so then the next thing I had was this discover macro, and discover is basically the thing that says it scans your entire hierarchy of modules and tasks and then turns them into a data structure such that you can run those tasks from the command line. Yeah, and there wasn't really any problems in converting that macro as a very, almost line for line. I could just translate it exactly as it was. Yeah, so as I said, there was no support in the main args library for path-dependent types and var args. And the reason I had to fix main args as well is because it's used by this discover macro to basically do command line parsing for commands. And commands are tasks that you can run from the command line. So again, yeah, I just published local all my fixes and then made a pull request to main args. Here's a little fun thing with the Scala 2 macros. In Scala 2, you can just put an import inside a quasi-quote, and this import will just be spliced wherever you call the macro. And this is basically duck typing, because actually this macro is defined in this define module. But this little import actually comes from the main module, which depends on that. So statically, it doesn't even exist at this point in the code. So this would not be able to convert to the quotes and splices. So in the end, I basically just copied this to everywhere where we call this discover macro, because that's the only way to fix that. Yeah, so basically, Scala 2 macros are completely duck typing. And that's pretty bad if you're trying to convert it to the new type-safe Scala-free quotes and splices. Yeah, so next thing, there's a macro called the enclosing class. And all it does is it splices in this piece of code, create me the enclosing class with this dot get class. And again, this is just magic duck typing, because when you substitute the code at the call side, then sure, that this refers to the this where you call the code. But if you try and convert this to quotes and splices, it tries to resolve this, and it will actually be this object here, like the definition of the macro. So we have to get rid of this ugly duck typing. I mean, it looks beautiful, but doesn't work in Scala 3. So you have to dip down to the explicitly duck-typed reflection API. So I have to just find the symbol of where I call the macro. So that's a symbol splice owner that gets the symbol of the place where you call the macro from. And then I look outside that to get the first class I see. Then I constructed this. Then I have to convert the this to an expression of any. And I went from the unsafe duck type, just look up the symbol, cast it thing, to an actual now type safe expression of any. And now I can call the get class on that type safe expression. So this is the ugly part, and then we go back to the beautiful splices. A very similar story with the caller macro, which basically says, where was this method called from? So just construct caller with this, the exact same story, except it's kind of broken, and I could not port this to Scala 3 because let's say we have this example here where this is actually some mil code where you have a module foo, and it will get inserted this extends base class, and the context extends this caller thing. And in Scala 3, when you do the enclosing class thing in the parents of a class, and it will actually refer to foo, which is it will become foo.this, which is impossible to do in the parents of a class, so that's a compile time error. And really it should have been package.this, not foo.this. So that's just a complete compiler bug, no way to fix that. So instead of doing that, I just moved the caller to not be a macro and just put it in the module trait, and then no macro, and it's just available, and it's the only place where you actually need the caller. It's always a module in the end. So I think this is a good solution. Okay, so now we come to the main sort of fun part of mil, which is the task macros. So if you write some code like this, you have a task, which is really horrible. So we have the foo, which is just a task that returns an int. So we're going to repeat hello foo many times, and then we append bar, which is some string. And the macro converts it into this mess. So what is this? First, we have cache target, and that basically is just receives some no-arg lambda and just stores it in a hash map with this basically like a path to say the task called myclass.cukes. So yeah, we store this in a hash map. Then we lift out the foo and bar as tasks into a list that goes up here. And then basically this evaluates foo and bar before we run the code inside. So we want to have a happens before. So we have foo and bar happen before this body here. So then these args is basically a list containing the results of evaluating this.
So this is fundamentally the same as the task macros in SBT?
Yeah.
Okay.
Yeah. Yeah, so I guess the whole point is there's no so you can introspect the whole graph of tasks. Yeah. Yeah, and yeah, as I say, so this foo just ends up casting the first argument of this args, and there we go. That's how that works. But again, we're hit by the duck typing of Scala 2 macros. So in the old thing, we just call this traverse context here. And we just say, splice in the this of wherever we are right now. And we're in a completely different file to the call site. There's no relation to what we have here. And also, this traverse context thing is just find me any old traverse context. I don't care which one it is. So it's again duck typing because it could be even in a completely different base class, and it would still resolve it correctly in this Scala 2 macro. So the only way to solve this in Scala 3 is basically to explicitly resolve the traverse context in a separate expression here. And so I have to splice it in the implective macro. So I lift it to the implementation of the... So you see, before I had implementation, and we just have this expression here. That's all I had before. And now we also pass in a function that tells you how to resolve the traverse context function. And yeah, we splice it in at the call site here, basically. And apart from that, the Scala 2 macro used this reify and splice thing, which is a very magic thing in the Scala 2 macros, and that pretty much converted directly to quotes and splices in Scala 3, so that was nice. That was a nice conversion to do. Yeah, so let's do a quick review. After I'd fixed the discover macro, the enclosing class, and tasks and applicative, I could pass this test. So that was pretty good. I opened the pull request and passed that. And this test basically passed for free. I didn't have to modify the test or anything. It just passed. So then we come to the rest of everything else that doesn't pass for some reason. Yes, so the next thing was basically this module defs plugin, and what that is basically a plugin that says you don't have to use override in a module. I guess that's just a usability feature. Yeah, okay. So yeah, if you implement a task or override the method, then you don't need to explicitly say override, and we just have this plugin that does that. And also, it for the inspect command, it basically in mil allows you to read the documentation of the task. So there's a plugin that goes through the Scala doc and just puts it into an annotation on the class, so reflection can access it. So I just had to implement that. And this is how the auto override looks like. You basically just look at a method, and if it overrides something that is not abstract and we're inside a module class, then we just add this override flag. So these were actually quite simplified compared to the Scala 2 implementation. So that was happy. It took like a couple of hours to do this. Yeah, so then the biggest macro change I had to do next was this cross factory. And this is actually a quite impressive macro because you just pass this single argument and it basically turns it into this huge thing that can construct any module for you. So one little part of it is that we basically map the arguments in this thing and convert them into a module for X and a module for Y. So for each one of these, each of X and Y, then we're going to construct an implementation of our foo module by basically this factory method that passes in a context, and we assign the cross value to the argument of the lambda. So this is pretty verbose. It would be really cool if you look it up in the macro code, or maybe some other time I can explain how it works. But yeah, we did have a bug in Scala 3, or a problem at least, because here's a little piece of that generated code. We need to create a class that extends the foo module. The problem is that this module thing extends that base class earlier, which requires a context. And we have to pass that context in a lambda. And because this foo module is like a dynamically passed thing to the macro, we don't know what it is when you because it should work with any type at all, which means we have to use this new class untyped macro. We can't use the quotes and splices. We have to use this new class untyped thing. So we have to pass the parents explicitly. And basically, there's no way with this method to declare parameters. So I basically, with reflection, just cast the quotes object to the compiler's own context and defined my own little wrapper that allows me to define a constructor symbol here. So, and in this, I made it really simple, just the names of the arguments and the types of the arguments, and only support one single parameter list, just enough to do that one example use case. And I created an issue in the .e repo, so someone is working on that right now, so I'm happy with that. Yeah, so the next thing was quite problematic is this line numbers plugin. And why do we have this? Basically, when you define your little mil script, like in Scala 2, you just have these top level expressions. So you could just have a print line at the top line of your mil file. And so mil wraps that list of statements into basically an object, or even an object. So we have a lot of generated code, and we have about like 25 lines of stuff at the top of the file. So we need to adjust the line numbers so that they show up correctly in your IDE and in the bytecode and in error messages. But there's a big problem because in Scala 2 this was done with a compiler plugin, and that can and the effect of a compiler plugin can happen at the earliest stage of compilation. In Scala 3 there's a restriction that plugins can only run after the type checking is finished. So any parsing errors or any type checking errors would have the incorrect line numbers. If we implemented it correctly in a plugin. So we had to do this thing where basically before we do the type checking, anytime the compiler produces some error, we have to look at that error and replace all the line numbers with this offset. And that's pretty easy in SBT and Zinc, because Zinc is part of SBT that wraps the compiler, and it allows you to customize anything to do with the way it reports errors. So you can easily inspect the position of an error and just modify it however you want. And that also works with BSP, because Build Server Protocol, which is how Metals interacts with Mil, and Metals is one of the IDEs you can use with Scala. So basically we just wrap that Zinc wrapper and it just trusts that. So we only need to modify one place. But the thing is, modifying the reporter isn't enough, because the bytecode needs to change, the line numbers in the bytecode. So we had a real hairy mess trying to fix that. I don't think I'll talk about that because it's quite complicated. So yeah, the next thing here was that basically we had this code sig analyzer, and yeah, why do we have that? So when you run a task, the result is cached. If you have a side effect, such as printing or writing a file or something like that, then anytime you update the definition of your task, you would prefer that side effect to be rerun and actually work. But if we only cache the result, then all those side effects basically disappear. So we need a way to analyze that when you change these side effects in the body of a task, that we actually run the task again. And the only way to do that is to basically look at the class file and look at the bytecode and say, did it change? There wasn't really anything I had to change with this. It worked pretty much the same, except lambdas in Scala 3 have a different representation than in Scala 2. And basically in when I changed to Scala 3, they were just being skipped. Any lambda that was being used as the body of a task was basically being skipped. So they were not being analyzed at all, so nothing worked. So basically nothing worked at all. And all I had to do was change this very small piece of code that says, skip it if it has 0 arguments. And I just say, oh, actually, if it has 0 arguments and it comes from a task, then don't skip it. So it was a very small fix, but it took ages to even debug and find out how this happened. Yeah, and then the next step was basically we had fixed all the macros, all the compiler problems. You would think it's all amazing, but really now we have all these terrible, terrible dependency conflicts. Scala FMT not working, Scala fix not working, twirl compiler not working, because twirl, when you use it from Scala 2.13 or even Scala 3, uses Scala 3 syntax, and then you try and use it in a Scala 2.13 project, and then that doesn't work. So then I had to hack that to figure out, oh, actually I need to give it the 2.13 one instead, even if you set your code to Scala 3. So this just took a lot of effort to even get through that. Yeah, so then at that point, I'd actually passed every single test in the CI, but the journey was still not over. I had a completely green CI and it's not done because it had 0 support for Scala 3 at this point. Like, all we could do is just, yeah, sure, we were compiling the code with Scala 3, but the parser is a Scala 2 parser, so it was only allowing Scala 2 syntax. So no enums, no optional braces. So I had to write my own Scala parser. I didn't really write my own. I reused the Scala 3 parser from the compiler, but I had to do a lot of customization on that. But anyway, the status quo is that Mill uses the fastparse library to implement a Scala parser, which basically re-implements the Scala 2 parser. Could we modify that to work with Scala 3? I don't really think so, because parser combinators are like context-free, and indentation syntax is not context-free, so I don't think that would work. There's also the Scala meta parser, which exists. I think we could have used that, but that means, you know, an extra third-party dependency. But on the other hand, it means we don't have to do crazy class loading hacks. So I wanted that one, but in the end we used Scala 3's own parser. So how do we do that? Yeah, there's a lot of problems with that. So number one, you're trying to compile the mill build file using Scala 3, but at the same time you need to completely you need to parse the mill build file again to check if it's formatted correctly, whatever. And this has to happen in a completely separate class path to avoid any conflicts dependencies. And the other thing is, yeah, we have to maintain compatibility with the old way, which just basically use strings, pass strings, return strings, pass them again. So I factored out the old Scala parse methods into this trait, and yeah, and then basically I implement this trait from another project, and then I load it with reflection and cast to this thing. Yeah, and this is how we load it with reflection. Basically, we have to, in the build file of the runner project, basically I write the class path to code-generated code, and then it's basically the list of Maven dependencies. And then at runtime, I read this list of Maven dependencies and resolve them into the class path of the Scala 3 compiler. Then I load that with reflection, and then I can call those methods. Oh yeah, and then basically this task is the thing that basically loads the compiler with reflection and caches it in what's called a worker. And a worker is like a long-lived object that will live as long as, if you're using mill server, then as long as the server is running. So when you have to load it one time, and then we can run it, I don't know, hundreds of times. So that's pretty good. And then yeah, then also there's this thing that basically when you run a mill build again, it basically writes all the class path of everything that needed to load it to a file, and so we need the class path of the original. It's basically just caching loading of that thing. Yeah, and basically here is what it looks like to customize the parser. So what I do is I take this thing called an outline parser from Scala 3, and what that is it only looks at the top level definitions, doesn't read the right hand side, doesn't look inside objects or classes. And this is how we construct the compilation unit. So a compilation unit is just the top level file. And we treat it like the exact same as Scala 3, but then we say when you go inside a package, instead of doing package statements which don't allow expressions or things like that, then we just treat it like the body of a template with this template stat seek. And what is a template? It's a trait, it's an enum, it's a class, those things. And this makes sense because all that code that you write in the mill file will just get pasted into the body of an object. So this is the correct thing to do. And then I have to basically traverse all this and split up the trees into the strings from the file, separated by white space, to just get the top level statements. Because we have to go through each of those statements and look for custom import statements. Yeah. Okay. So after I'd done that, we actually were done. So yeah, I could do that code that I showed you earlier in the demo. And we're still in the process of merging the pull request. There's a lot of rebasing that still needs to be done. And on my website, I have /projects, and you can read a lot more detail what I did, because I basically kept a diary of every day I worked on it, every problem I had, every little thought I had, it's all in there. So I'm done. Any questions? I hope it wasn't too confusing. Yes.
When you migrated some macros like the cross module one, have you stumbled upon compiler bugs like failing assertions? Like when I tried to port it myself, I often had a failing assertion, no denotation.owner, and I think I have opened like 10 issues. 10
oh, really?
Issues. It was not in Scala 3.5, it was in Scala 3.2, if I remember correctly. So were these bugs patched?
I guess. I didn't really have any issues with the compiler except the one I said with the enclosing symbol not being correct in if you try and call a macro in the extends clause. That was the only bug I could really find. And apart from that, yeah, no crashes. Yeah.
I have a curiosity question. Why did you choose Scala 3.5.0? I mean,
oh, yeah.
I know it's not library mill, but you have to write plugins for it, right? If you can write, let's call it userland plugins. And I can imagine that you would have chosen like the Scala LTS version. So I was just wondering why 3.5.0 specifically.
Might have to be a question for Liaoi.
I think it's pretty arbitrary. Like it's a new version, it's the newest version of Scala, and we have to use the newest stuff. I don't think there was that much thought put into it. Yeah.
And I'll just add to that. Like I think as a migration strategy, it's reasonable to actually begin by using latest Scala because it's the highest quality Scala. And then back, if you later decide that it needs to be on LTS, backport it and see what trouble you have. But like to sort of to get to using the best Scala, I think is the fastest way to get to something initial that works.
Yeah, seems reasonable.
Mm-hmm.
Thank you.
Actually, it's a good point because a lot of the macros, I was using new features that were not in the LTS branch at the moment, so that would be a bit difficult to support that. Yeah.
Were the error messages improved in Mil Scala 3? Like when you wrongly define a task, sometimes you have a bit unhelpful errors, like which looks like typical Scala 2 macro errors. Are they no better in the Mil Scala 3?
I do remember I did change some of the macro errors, particularly like at least in the cross macro, because sometimes, you know, if your value doesn't match what the cross value expects, then you had a very vague error. And I instead made it more precise to say like, this exact value needs to be this exact type, but actually it was this type. So like, you know, the typical expected this but found that. And I think something also with the task macro, when you reference, I don't know, like sometimes there's some places where you're not allowed to use a reference, and I probably made that more specific, the message. Yeah. Seth.
You mentioned some places where the increased type safety of Scala 3 macros actually got in your way.
Yeah.
I'm curious, like overall, are these macros simpler, better, more elegant on Scala 3, or was did the Scala 3 design just purely get in your way?
Right. No, I think it was a lot nicer because you can just define things a lot of the time with an actual lambda expression that has like these typed expressions, and you just splice them in. I don't know. I think it made it a lot easier to write a macro because you can just trust the safety of splicing an expression should just be correct. It was really hard, just some of these weird duck typing things like this prefix method. And prefix is pretty magical. It just is just, I don't really know. It just like either becomes the thing dot this of the surrounding thing, but yeah, I don't know. Apart from that, I would much prefer the quotes and splices. Yeah.
It seems you've been very careful to keep the mill model of the build, the existing one, without breaking anything.
Mm-hmm.
Have you come across a situation where you thought perhaps if we change it a little bit, we can use that feature that will simplify the implementation?
Mm-hmm. There is with a recent change, which is we have like arguments that you can pass to the task macro, so you can say, or a command. So you can say like this command is persistent, I believe, or exclusive, like runs on one thread, and yeah, in the Scala 2 way, they're using like one of these dummy classes that just has one argument to just allow you to separate two type parameter lists from each other. And in Scala 3.6, you can actually just do that in a single method. You don't have to like you can have multiple type parameter lists in a method. So that would have been something that would have been nice to save till Scala 3, but I guess for backwards compatibility, we have to keep it like that. Yeah. Yeah, other than that, it was just, you know, I think the tools in the Scala 3 macros gave you more thought to say, I can actually make a nice error message because I can precisely capture the things that went wrong. And actually, there was a lot of improvements to, in general, the signature of like the applicative macro. Because before, I'm not sure even know how it worked, because when you convert to the coarser splices, you had to be very precise with the exact types that you're using and splicing into everywhere, because they have to be captured in these type class arguments. So it ended up becoming more understandable. Yeah. Any other question? Okay. It's good. Thank you for coming. And yeah, there's a lot I didn't cover, like specific macros. Like, I don't know, maybe I can either write about them in the future or come talk to me about any problems you have.